And welcome to another GCBASIC demonstration. This is part 17 for the 18FxQ20 chip family. This is a video on Configurable Logic Cell, or CLC. I will only call Configurable Logic Cell CLC from now on. So, do like and subscribe to the video. Eventually I'll get my numbers up and be really good. Okay, using CLC. What is CLC? Well, it allows you to create custom logic inside the hardware that requires no CPU cycles to make it work. You can do some really simple stuff to some really complex configurations when using CLC. Let's see it in action to start with. Action. I've got a Q20 attached under the here. I've got some LEDs attached to the Q20 via these leads. When I push this button, that blue LED comes on. Other things could happen. I've just made this switch depression, make that LED come on with no code. I mean, there's obviously registers to set up the custom logic and to set that as an output, but in the do loop, there is no code, there is no interrupt. And we'll see how to do it. We're going to do that, actually. That's what we're actually going to do. So you can create and or XOR etc. gates in there. You've got sequential logic. You can select your inputs. They can be timers, physical ports like I have it, external signals, and you can have outputs, and they can go to other peripherals and other IOs as I have it. So I have an IO pin as my input and another IO as an output. And you can create custom things like pulse width modulation signals. I have done that, and there was a demonstration on that, how to set it up. It is great. You can do data signal modulation to create completely customized protocols. And as I've done here, I'm controlling an LED, but you can do that more sophisticated in the time that I've got available. CLC can be quite scary. I was genuinely concerned until I put my own diagram together. It explains it like in this black diagram. It says the inputs are connected to logic gates, and the logic gates are then connected to an output. There's some signals. There's 4 different types of signals, A, B, C, and D. That's not what they call them, but just think of them as that for the time being. Some logic gates, and then that output to I/O and peripherals. And so what you need to do is set up the input signals on the top box, set up the logic gates, and set up the I/O pins. And it's all about getting those layers 1, 2, 3, and 4 there laid out. The inputs, logic gate configuration, sequential any logic if you need it, and then some output. Because that's a lot easier to explain than this, because that's what we're actually going to implement. We're going to implement a primary input, which is the switch on RA3. We're going to have a logic gate, and then we're going to invert the output to turn my LED on or off, depending, because my input state is different. It's high, and when I push it, it goes low. I just need my LED to be the inverse of that. So I've got an OR gate right the way through, really simple. And we're going to walk it through. So what I've got, I'm going to connect my PPS here and this output to a PPS. Really simple. I'm going to connect this logic here to this gate here, and the rest of it is done. Oh, I must be honest, I've got to set that not there. And the rest of it just happens. So I'm going to walk you through how we make this happen. So what we're going to use is something called the Microchip Standalone MCC. It's not the big heavy duty MPLAB X. It's a little subset, and you should only get it from the second URL. The one that's above it, old version, don't use it. We've got that installed. I've done that, installed it, and then what we're going to do some configurations, and then for the CCL, oh, so sorry about that. For the CLC configuration, this part here, we're going to take it from a file that's been generated for us. And for the PPS, we're going to take it from another C file. And inside of GC Studio, we're going to set up the basic hardware and just merge the components. Test and enjoy. So, recap. Let's go back to the camera. Push LED. It works. Back to the screen. Well, in here, I'm going to load up PIC18 Plus, and I'm just going to erase that chip. Descam, push that switch, nothing happens because I erased it. Really quite a lot. I pushed the erase button on there like that. It was really quite simple. Let's go into the code and see what we can do. So inside of GC Studio, I've got some code already set up for you. Control B will bring up the list. I want using CLC. Select that, and it will bring up some code. And we'll just have a quick overview before we go into the MCC tool, which I might start in the background because it takes a few seconds to load. Windows, MCC, MCC, and there's the icon. It's, if you can't see it, I'll bring it in. Where is it? I'll put it like that. MCC. I will get this sorted eventually. So you can see it, MCC. MCC. Standalone. Click on that. Back to my, and I'm just going to leave that running in the background because it will take a minute or two. It will. It takes a little while to work, but there you go. File. I'll have to zoom in for you. File. Standalone configuration. See this path here? Just take a copy of that. Open up Explorer, and all I did was accept the configuration there, and just open up an Explorer window with that in it. So what I've just done is opened up an Explorer window with the MCC on it, and that's the folders that we're going to be working from. I'll just leave that there for the time being. Select my chip, Q20, and I will select 16Q20 slightly off screen and press OK. And we'll leave that running because it takes a while to get it all set. It just takes its time to get set up. So in here, I've got, in my source program for GCBASIC, I've got hardware 16Q20. I've got exactly the same header here, create some constants for the port, set the ports as output, define a constant for the switch, set it as an input on port A3. And look, there's no code in here, it's just a do loop. And what we're going to do is we're going to fill in the blanks here. We're going to go and steal some PPS, and we're going to steal some CLC. Can't be hard, can it? Well, here up, back to MCC. Let's go stealing. Select the melody option, and then on the screen, select finish. Now, I have got my input on RA3, which is also the master clear. So we need to sort that out before we can use an input, and then we can add in the CLC. And it's relatively simple because if you look at the screen logically, we'll be able to work out how to do this. Let me just show you what it says at the bottom. It's start a new configuration, going through to loading all the cores. And in actual fact, we can start at the bottom in the grid view. This is great because look, this is the grid view, the default, and I want to use RA3 on my CLC, and I can't because I just can't. You can't unconfigure it. You have to actually do two other operations to make that work. If you want that as an input, you have to go into do two operations, and they're all inside the configuration bit. So if you go in here, click on the configuration bit, it will then load up on the left-hand side of the screen. I will cursor across onto the left-hand side of the screen so we can see it. A load of bits here we can set, and the first one we want to set is LVP programming, so we only use high voltage programming, not a problem, because you could just, now where is it? Which config number is it? Anyone like to guess? Don't you just... I'm talking to myself here as well. Oh, there you go. HV on master clear. So I've just turned on that, which is, and if you look at the bottom in a moment, and then find the master clear and set that so I can use it as an input. Now, down in this diagram here, in the bottom lot, you can see a marked difference here. I can now select it as an input on RA3. Now what I want you to do is add in the driver called CLC. In the device resource pane, open up the drivers, open up the CLC and add the CLC. And you'll see in the pins, as this all happens, that we get another set of options appear in the pins. And I want to select my input as RA3 on that particular CLC. If I actually click on it, it would happen. And then I want to take C7 as my output. And all that does is just the controls the PPS to link the PPS functionality to the CLC. Now, in this dialog here, it's a bit confusing because you've got this very large window which is all about the builder, but what you need to do is just drag this to the left, drag this to the left, drag this to the left, and look what's appearing. The diagram we saw in the PowerPoint presentation. And if we pull it down just enough to about there, look, we can see the whole thing that we need to see. So the first thing I'm going to do is I'm going to change the logic cell mode bits to OR or XOR. Now I've got my logic gate set up. I'm going to connect my CLC input, which is CLC in, which is on the RA3, remember, to that logic gate, and I'm going to invert my output by clicking on the output there. Now, if we just move our eyes to the left, on the top right, we can see the word generate. Click generate. And that is everything we need to do. Recap, for me, because I want to use RA3, I had to change the master clear on the programmer. But for you, you just need to worry about the logic cell mode bits, select your inputs, and select your outputs. Great. Let's go back to taking some code. Here's my file explorer, as you saw before, and I'm going to open up two files. MCC generated files, go into System, SRC for source, and open up the pins. Double click that, that will take it into GCCode. And in MCC generated files, CLC, SRC or source, take the CLC source. Let's have a look at the pins. Well, I just need to steal the PPS registers. There we go. I shall copy that into my PPS portion here, into my CLC, look for the init. I think there's only one. How many functions are in here? Two. Someone ought to write a function for that. Control C that and put that inside my GCBASIC source above it. It doesn't matter where you put it, just needs to go above the do loop. Okay. Full screen. Function key F5, hex and make the program, or you can press this icon at the top right hand corner. You can press function key F4. There's a whole series of ways that you can do this, and now it's compiling it up. It's going out to the standalone programmer. Oh, let me just change to the desk cam. Has it done it? Why is that not working? Oh, it is working. I pushed the wrong button. Well, that was a surprise to me that it didn't work. Look, it's working. So, really simple. Really very simple. All we did was, as shown on the screen here, I'll get rid of the red lines for us, is we used MCC. We took the CLC piece from that particular source file. We took the PPS from this particular source file and just merged it together inside of there. And you don't really need all the other stuff that's in my source program. It just works. Enough. CLC stuff done. Great. Next time, GCBASIC toolchain. I've done that many times, but it keeps evolving, so I have to keep doing it. Like and subscribe. Thank you. Enjoy.